In the year 1929, Edwin Hubble, an astronomer at Caltech, made a critical discovery that our universe is expanding. He proved that every galaxy in this universe is going far away from each other. But today's astronomers have found out that there are a few exceptions where some of the galaxies could eventually merge with other galaxies due to their high gravitational pull. The Andromeda Milky Way collision is a galactic collision predicted to occur in about 4.5 billion years from now. Now the question arises, could the stars and planets collide into each other? What about our solar system? What would that look like from Earth? And what are the other possibilities of this collision? Let's have a look at this. But first we have to know about galaxies. Now in a brief, galaxies are huge collections of stars, gas, dust and dark matter all bound together by gravity. Many galaxies have supermassive black holes at their hearts. There are four distinct types of galaxies: elliptical, spiral burst, and irregular. Our home galaxy Milky Way and our neighbor galaxy Andromeda are both a spiral type galaxy. Now come to the Milky Way galaxy. Milky Way galaxy contains the solar system with the name describing the galaxy's appearance from Earth, a hazy band of light seen in the night sky formed from stars that cannot be individually distinguished by the naked eye. The Milky Way is a bare spiral galaxy with a diameter between 150,000 and 200,000 light years. It is estimated to contain 100 to 400 billion stars and more than 100 billion planets. The galactic center is an intense radio source known as Sagittarius A stars, assumed to be a supermassive black hole of 4.1 million solar masses. But what about the Andromeda Galaxy? Andromeda Galaxy, also known as Messier 31 or NGC 224, is a spiral galaxy approximately 2.5 million light years from Earth and the nearest major galaxy to the Milky Way. The Andromeda Galaxy has a diameter of about 0.2 million light years, making it the largest member of the local group. The number of stars contained in the Andromeda Galaxy is estimated at 1 trillion, or roughly twice the number estimated for the Milky Way. The Andromeda Galaxy is approaching the Milky Way at about 110 km per second as indicated by the blueshift. Until 2012, it was not known whether the possible collision was definitely going to happen or not, but in 2012, researchers concluded that the collision is sure using Hubble Space Telescope to track the motion of the stars in Andromeda between 2002 and 2010 with a subpixel accuracy. Andromeda's tangential or sideways velocity with respect to the Milky Way was found to be much smaller than the speed of approach. Therefore, it is expected that it will make a head-on collision with the Milky Way. Such collisions are relatively common, considering galaxies' long lifespans. Andromeda, for example, is believed to have collided with at least one other galaxy in the past. The studies also suggest that M33, the Triangulum Galaxy, the third largest and third brightest galaxy of the local group, will participate in the collision event too. So how will this galactic smackdown play out? At their first close approach, the two galaxies will be about 420,000 light years apart, or far enough from one another that their glittering disks will not interact. However, galaxies are embedded in a large amount of dark matter, and as the Milky Way and Andromeda pass one another, those dark halos will snag. That causes friction, which causes them to slow down and lose energy and fall back together. Now this will happen over and over until eventually those collisions have sculpted them into a single galaxy named as Milkomeda Galaxy. While the Andromeda Galaxy contains about 1 trillion stars and the Milky Way contains about 300 billion, the chance of even two stars colliding is negligible because of huge distances between the stars. For example, the nearest star to the Sun is Proxima Centauri, about 4.2 light years. Visualize that scale. If the Sun were a ping pong ball, Proxima Centauri would be a pea, about 1000 km away, and the Milky Way would be about 30 million km wide. Although stars are more common near the centers of each galaxy, the average distance between stars is still 160 billion km. That is analogous to one ping pong ball every 3.2 km. Thus, it is extremely unlikely that any two stars from the merging galaxies would collide. But what about the central black holes of the two galaxies? Will they merge to form a more massive black hole or not? Let's see. The Milky Way and Andromeda Galaxy each contain a central supermassive black hole, this being Sagittarius A star and an object within the P2 concentration of Andromeda's nucleus. These black holes will converge near the center of the newly formed galaxy over a period that may take millions of years due to a process known as dynamical friction. As the supermassive black holes move relative to the surrounding cloud of much less massive stars, gravitational interactions lead to a net transfer of orbital energy from the supermassive black holes to the stars, causing the stars to be slingshotted into higher radius orbits and the supermassive black holes to sink toward the galactic core. When the supermassive black holes come within the 1 light year of one another, they will begin to strongly emit gravitational waves that will radiate further orbital energy until they merge completely. Now, two astronomers with the Harvard-Smithsonian Center for Astrophysics stated that when and even whether the two galaxies collide will depend on Andromeda's transverse velocity. Based on current conclusions, they predicted a 50% chance that in a merged galaxy, the solar system will be swept out 3 times farther from the galactic core than its current position. They also predicted a 12% chance that the solar system will be ejected from the newly formed galaxy sometime during the collision. Although there is a possibility that our Sun will become a red giant about 5 billion years from now and will eventually swallow Earth, solar system's habitable zone will shift toward the Saturn and Jupiter. But what about us? We will have to leave Earth and find a new place to live. Maybe at some time humans are managed to colonize in other planets. Europa, Titan, Mars will be the options to make colonies. Maybe we will have to leave our solar system and have to search for a new home in Milkomeda Galaxy. Maybe they will transfer themselves into a transhuman. Maybe long before the collision, humans will disappear from the Earth. Then the mRNA might spread throughout the universe during this collision, and in a suitable place, this creates a new form of life. Now, these collisions help the nature to recycle new form of lives. This is how the collision is so important. Maybe long after this collision, someone like me is once again discussing how the collision of two galaxies lead to a new form of life. Thank you.